In this video, I'm going to teach you how to simplify a cross product or a dot product by using all the properties of cross product. So before you watching this video lesson, you have to go through my video about the properties of cross product, right? So you can get that link through my lecture notes. All right. So let's look at this. We have A cross with A minus B. As you know that this is distributive. All right, cross product distributive means that we can distribute A cross A multiply just like doing normal expansion, negative with A cross with B, right? A cross with B. So as you know that this is the properties here. This is the properties here. As long as you have two parallel vector, or we said, listen, this is very important, as we have two identical vector. All right. So when you cross, you are getting a zero vector here. All right. I have explained why A cross A will be zero vector. It's based on the definition of vector product, right? The formula for vector product. So you can refer to that video for further information. And this you are getting zero vector minus with A cross B. As zero vector, just if you add with another, you just get back that vector, negative A cross B. Or you can rewrite negative A cross B by reverse B cross A, but it will become positive. Alright, because why? You know that A cross B is the same as negative B cross A, right? I also can say B cross A is negative A cross B, or A cross B is negative B cross A, right? So it's okay, or you just leave it in this form or this form, right? So this is the simplification of this case here. Okay, let's look at this. Usually students were expanding, right? They were using distributive law, so they will be expanding. It's okay, but a smart student will know this is actually a cross product between two identical vector, right? If you see A plus B is a vector, A plus B is also a vector, and these two vectors are parallel. They are the identical vector, right? So it means that based on these properties, A cross A, you are getting a zero vector. So an easier way of doing this will be, as long as these two vectors are parallel, and this is happen to be this and this are the same, right? Parallel, and they are the same vector. So definitely they will getting a zero vector. That is the simplification here. Okay. If you want to use expanding, it also can. Okay. Alternatively, this is the best lah. So then you're taking A cross A, right? A cross with A. I want to show to you why is it zero, right? And the fast way of seeing this is two identical, you are getting zero vector. So A cross A plus with A cross B, right? Sir, why it will become zero? And I show to you now. All right. So plus with B cross A. So B cross A, and lastly you have B cross B. If you see that A cross A will become zero vector, right? Will become zero vector. All right. A cross B. I just write back A cross B. What is B cross A? B cross A is negative A cross B. Right, it's negative A cross B, and B cross B is still the same vector, right? Follow these properties, B cross B, you're still getting zero vector, and these two vectors happen to be the same. When you minus, you're getting zero vector, so the whole thing will become zero vector. That's all the explanation, right? Okay, let's move on with the next example. All right, let's move on with these examples. So A minus B plus cross with A plus B is not zero vector. For these two, it's not zero vector because these two is different vector. A minus B and A plus B is two different vector, right? They are two different vector. One is minus, one is addition, one is subtraction. So I'm going to expand as usual. So A cross A. So A cross A. So followed by positive A cross B, right? And negative B cross A, right? Negative B cross A. Negative, positive, negative B cross with B. All right. So you shouldn't write this to be a square, alright? A cross A, this is a misconception, alright? This is a misconception. This is not a normal algebra. It does not represent a number, right? It's a vector, right? Don't relate vector to a normal algebra, right? Vector, we study vector differently, right? So this is a very important thing that you must remind yourself. Alright, so A cross A, as long as you see two vector which is identical, you are getting 0 vector, right? And this also will be 0 vector. This is only for cross product. So, and A cross B, and what is negative B cross A, right? As long as you reverse the process, A cross B is a negative B cross A, right? If you reverse these two, A cross B, the negative will turn to be positive. Or we can just say negative B cross A is A cross B. So this everything will become A cross with B. And this 2 is actually identical and with addition. So we can say that it will be 2A cross B. 2 times A cross B. So this will be the result of this problem. Alright, this is the result of this simplification. So let's go on for more examples so that you understand how to use the properties of vector product. Alright, let's look at these two examples so that you have more understanding about dot product and cross product. Alright, so if you look at this, so this is okay, I cannot do, there is a cross product and a dot product, and this 3 is a vector, right? This is a vector, and this is a vector, and this is also a vector. So I cannot doing dot product first, right? What is the problem? Because when I doing dot product between these two vector, right? Between these two vector, so you will produce another vector, produce a scalar, right? Because dot product, this is a vector and a vector, you do dot product, you are getting a scalar. How come a vector cross with a scalar? That is meaningless, right? Meaningless. So what we're going to do is we're going to do the front one first, right? Because you know that a vector cross with a vector, you produce a vector, right? You produce a vector, and this vector dot with another vector, you're getting a scalar. So it means that whole thing here is supposed to produce a scalar quantity, alright? A scalar quantity. So now, okay, I just showing you. So first I'm going to doing this, right? I'm going to doing this. So A cross B, I'm going to expand this into A cross with B. So plus with A cross with C, right? A cross with C. This is a proper way of doing cross product. A cross B plus with A cross C based on the distributive law, right? And everything here, okay, this is everything in the bracket, you're going to dot with B. And only you start doing dot product. And now coming with this vector, dot with vector A, right? And dot with vector B, right? This one dot with vector, and this one also dot with vector B. So A cross C dot with vector B. Finally, what can you observe about this? If you're very good, you have understand the concepts, right? As you know that A cross B, when you dot with B, you are getting 0. Okay, you are getting 0. Or I said that A cross B, if I dot with A, I also were getting 0. As long as after you're doing the cross product, you dot with a vector, and this vector is inside the cross product, inside the process of cross product, you are getting 0. For example, A cross B, okay, or I said B dot with B cross A. It's still the same, because B is inside the cross product and you dot with this, you are still getting 0. Or if I setting A dot with B cross A, you are still getting 0. Okay, there are many ways of writing this. Okay, so now this is based on the result of if I have A and B. If I doing cross product, I will getting a perpendicular, normal vector, right? A perpendicular vector to B and A. So based on the scalar product of two perpendicular vector. For example, A cross B is perpendicular to A. So scalar product of these two, you were getting 0. That's the properties. So for this, you were getting a 0, right? You're getting a 0. And for this, you can't further simplify because B is not in the cross product, right? If this is B, then B cross C, then dot with B, then this whole thing will become 0. But because B is not inside the cross product, so it's not 0. So if you simplify, you are getting, okay, finally, you are getting A cross C. This is getting 0, so the remaining will be getting A cross C dot with B. This is the final form, which cannot be further simplified. Alright, I hope you understand about this, and I apply this in here, and I'm going to do the cross product first and followed by the dot product. Alright, let's look at question 5. Alright, okay, let's look at this. Alright, let's look at this example. So if I have A dot, okay, I cannot doing the dot product first. So why? Because if I dot product with these two, A dot with a vector, I will getting a scalar quantity. Scalar quantity, you can't cross product between a scalar and a vector, right? It's meaningless. So what I do is I'm going to do the cross product first, which giving A and dot. Okay, now I'm going to put this as bracket. So A cross B or B cross A, right? Sorry, it's B cross A. The order, right? As you know, that cross product is not commutative. You cannot simply A cross B, B cross A. No, you must follow the order B cross A, followed by C cross A, C cross with A. Then only you doing the dot product, and A dot with B cross A, right? A dot with B cross A, followed by A dot with C cross A. This question is slightly different from this question. You try to see. Alright, B cross A, B cross A, C cross A, right? So if you go and dot with A, as long as you see B cross A, this is perpendicular to A, right? And because the vector A is inside the process of cross product, so you are definitely getting 0. And this is also the same, right? Because C cross A, right? C cross A is perpendicular to A. As long as the A is in the process, when you cross these two, this will be perpendicular to this. So this is also 0. The whole process, you are getting a 0, right? So hope you really can see. Or there is another shortcut here. Some students are very good in observing. So if you see carefully, alright, if you see carefully, B plus with C dot cross with A, right? Cross with A. Very important. Okay, try to look at this. If I said A cross B dot with A, right? I was getting 0. Why? Because A is inside the process of cross product. Same thing happened to be here, right? This is a vector and you cross with A, right? It's just like this is just like C cross with A. I assume this to be another vector, alright? Another vector can be alpha, alright? So this one cross with A. Can you see that in the cross product between these two vectors, right? There is a A here, right? There is a vector A here. So when you dot with A, this whole thing is turned out to be 0 also, right? Because this vector that you produce after you do cross product means that vector B plus C cross with A, when you do the cross product, this whole thing will be perpendicular to A as well, because inside the cross product there is a vector A, right? Which is involving. So when you dot with this whole vector, you are getting 0. This is another shortcut if you're able to see the properties carefully. Alright, so I will give more example, as this video will make sure you understand all the properties of vector product. Alright, let's look at this final example of this video. So I'm going to make the proof for all the properties in another video. Alright, okay, let's look at this. Alright, so as you know that you have to do cross product before you do the dot product here. So here I have stated clearly that you have to do the dot product, right? The cross product. So A cross B. So you're going to dot with this. So you're going to multiply this into, you have to do the dot product for each of these. A dot with A cross B, right? In this video, I talked many properties about okay, about this. So A cross with B, right? So if you see that A cross B, A is inside the process of cross product. So when you dot it, so you were getting 0, right? And this also will be the same. A cross B, if you dot with B, B is inside the process of cross product, you're also getting 0. So the whole thing will be 0, right? So these properties is very important. So I have to tell you that, so you know that A cross B is the same as negative B cross A, right? And you know that if you have two identical vectors, if you cross, you're getting a 0 vector, right? And A cross B, if you go and dot with A, you are getting 0. Or you dot with B, you're getting 0. So, so this is the first 3 examples that this is the 3 properties that I mainly talk about all the 6 examples here. I mainly use all these properties. Alright, so you understand, make sure you understand, know how to using these properties. Alright, so that's all for this video. Hope you understand.